welcome back, folks, to um, a recording. It's an interview with another luminary in the relevant fields to our phenomenon of interest. And this is our second episode, or this is our second time we're doing this. It's been almost close to a year since our first episode, but which was with Dr. Colm Kelleher. But it was never about quantity and volume for us. That's what Augustus and I had thankfully agreed upon very early on, because we're, at the end of the day, loyal to the foil. We're here for the juice. We're the tip of the spear, and we don't make compromises when it comes to the level of insight and impact that we can bring to any kind of exploration of ufology, of scientific advancements, and every other relevant topic of conversation. I also want to include here an introduction to Josh Freeman. He's newly joined the team. He is our third co-host. He's a wonderful wealth of information regarding the whole phenomenon, and he's been absolutely a massive help and great support in enabling the putting together of this particular interview. So on that note, I'm going to hand it over to you, Josh, to kick off the intros for Dr. Loeb.
Okay. Thanks for the introduction, and thanks, Dr. Loeb, for helping us out. And Avi Loeb is the head of the Galileo Project, founding director of Harvard University's Black Hole Initiative, director of the Institute for Theory and Computation at Harvard-Smithsonian Center for Astrophysics, and the former chair of the Astronomy Department at Harvard University 2011-2020. He chairs the advisory board for the Breakthrough Starshot Project and is a former member of the President's Council of Advisors on Science and Technology and a former chair of the Board of Physics and Astronomy of the National Academies. He is a best-selling author of Extraterrestrial, the First Sign of Intelligent Life Beyond Earth, and co-author of the textbook Life in the Cosmos, both published in 2021. His new book, titled Interstellar, is scheduled for publication in August 2023.
Fantastic. So unless, Dr. Loeb, if you have some initial preliminary thoughts that you might want to share with us, we can proceed with the regularly scheduled programming.
Thank you for hosting me. It's a great pleasure to join you. Just wanted to mention that I have every few days an essay posted in Medium, and I did post one just a couple of hours ago. The title is The Simplicity of Telling the Truth, and you can browse through it while we're speaking. And I'll be glad to answer any questions. This follows up on a publication of a paper in Nature magazine that argued that the first interstellar object that humanity ever discovered that looked really weird must be a generic iceberg made of water, and they just made a mistake in the calculation of the energy balance. And then reporters all over the world celebrated this paper on Thursday this week, just a couple of days ago. And within a day or so, we realized that they made a mistake in the energy balance, and the model that was suggested is wrong. That basically it's not viable because it violates energy conservation, which is a very fundamental principle in physics. So we wrote a paper about it, and I shared it with by now about 16 reporters that wrote a big story about the original paper. They put it out on Thursday, and I told them, look, there is this mismatch with energy conservation, and therefore you should mention that as a correction. This paper is wrong. And only two of them promised to do that, because two others said, we don't want to confuse our readers. And then you wonder, how can we complain about politicians misinforming the public when science journalists do not adhere to the scientific truth? They could have easily added a sentence saying, there is this new paper showing that the model is in doubt because it doesn't satisfy energy conservation. That's a very simple statement. They don't need to subscribe to that criticism. They can just mention the paper so people can look at that. But they preferred to quote unquote protect their readership from the truth. And these are science journalists. So when journalists that are supposed to report about scientific truth are doing that, how can we trust them on other matters, such as public health, such as whether COVID-19 came from a lab or from the wet market in Wuhan, such as what is going on worldwide in various circumstances? My point is, if they do it, we have no way of complaining about politicians doing it.
That was a wonderful take, Dr. Loeb. Yes, indeed. Who will guard the guards? That is the question. Um, but I would like to come back to that in a little bit, if you may indulge us. I would like to begin with some of the phenomenological questions that we were wanting to get your thoughts on, if you don't mind.
Sure, please go ahead.
So, within ufology, at this point, I believe it is my opinion that it is quite undeniable that the phenomenon itself is quite real. What its true nature might be has always been up for debate, and that conversation is still going on. The jury's still out on it, and in the process of that, there have been a number of, I guess the subsequent question becomes, what then is the best hypothesis that provides the best explanatory basis for the etiology of this phenomenon? And through the years, people who have been interested in this field have come up with a number of theories, and we could probably list them. We could enumerate at least quite a number of them, but the two major ones are the extraterrestrial hypothesis and the interdimensional hypothesis. I wanted to know your thoughts as a physicist, because and just for context, for the sake of context, I'm a machine learning professional. I've been in the field for the last 10 years, pretty much my entire working life, and it rather irks me the use of this word dimension because we deal with uh, curses of dimensionality all the time. So it becomes extremely hard for me to wrap my head around what exactly it is that people mean when they say that these entities, if there is an agent that can be ascribed to the phenomenon at all, come from some sort of other dimension. And in fact, over the last few years, this hypothesis, this camp, has been gaining ground over the extraterrestrial hypothesis that they're flesh and blood beings that arrive here in nuts and bolts aircraft from some distant star system very similar to ours, and from a planet very similar to ours. So, on that note, I would please love to hear your thoughts.
Well, I'm a scientist, as you noted. I'm a physicist, and I think we should be guided by evidence. So, at the moment, the evidence is not conclusive. People talk about their private experiences, but in science, we have to rely on instruments, recording. And the way I explain that is just imagine the FIFA World Cup in soccer, that we saw last year in Qatar. Imagine relying on what the players tell you about whether there is a penalty or not under some circumstances. That's not very reliable. People can say whatever they want. When there are car accidents, people involved give very different reports about it. It's the same event. You can't rely on people. And that's why FIFA is using video cameras to figure out what really happened. They're not going to ask the people involved what really happened and decide based on that. Therefore, if you're talking about the phenomena, we're not going to ask people what they saw, because this is just like asking the players whether a penalty took place. Okay, people have ulterior motives, they have wishful thinking, they have hallucinations, they have all kinds of things that guide them that have nothing to do with the actual event that took place, or maybe have some to do but not everything to do with it. So therefore, in science, what we do is not rely on what people tell us. We use instruments that record, just like FIFA used video cameras to decide about the penalty. They didn't ask the players, they just used video. And now this is the official way of deciding whether a penalty should be awarded, based on video cameras. Why? Because video cameras do not lie. They basically record whatever is out there, and you can have a large enough number of video cameras so that you cross-check from different angles, you cross-check from at different times. You can do the due of diligence and figure out what really happened. We don't have that in the context of unidentified phenomena that people report about. So as a scientist, I decided it's sufficiently intriguing to establish a scientific research project, which I called Galileo Project. I received funding at a few $1 million to Harvard University. And we already built the first observatory monitoring the sky 24/7 in the infrared, in the optical, in the radio, and in audio. This is the scientific method. Just like FIFA using cameras, we are using cameras. We don't go around and ask people, what did you see? That's not reliable. So when you talk about extra dimensions, when you talk about all kinds of interpretations, that's what people say. There is even a documentary filmmaker that said, oh, look at this hole in the sky. It looks like a wormhole. And then everyone said, oh, it is a wormhole. It is a wormhole. New physics. That's not the way science is done. If you see a hole in the sky, you cannot claim it's a wormhole. You cannot claim it's new physics. That's not, that's not credible. What you need is to collect data that will show that it's a phenomena beyond any explanation that standard physics can give you. Only then, once you cross that high bar, when nothing can explain it, only then you seek explanations beyond what we know. But just poor data, you looking at the sky and seeing a hole in the clouds, poor data is not sufficient evidence to say new physics. And that's what many people do not understand. The fact that you don't have good data doesn't mean that it's new physics. You need to have exquisite data, extremely good data, in
Incontrovertible,
order to
in other
argue.
words.
Yeah,
But sorry to
yeah.
interject, Dr. Loeb, because this segues directly into the second question that I was going to ask you. And while I was reading through your various articles on Medium, it, 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 it I was able to detect that you do have a very keen interest in technosignatures, right? The phenomenon is real. Like, we need to explore the entire possibility, entire solution space of possibilities of how it is that this manner of detection could occur. So the prior to the existence of prior to LIGO, it was there was no such thing as the detection of gravitational waves, right? Prior to certain remote sensing technologies, let's say, right, there was no such thing as hyperspectral imagery. So clearly there are gaps in our current understanding of physics and physics that we might understand better down the road. Now, on the basis of that, I wanted to get quickly into the issue of propulsion. It seems to me that we have a certain sort of approach to propulsion, our civilization, that is, right? It's combustion based. We burn things in a contained manner and expel them in the opposite direction to the direction in which we want to go. That's fundamentally what our approach is. Whereas it seems that with some of the latest and Department of Defense confirmed videos and FLIR imagery and their actual readings, right? It seems that whatever it is that is in the aerial phenomenon in our sky does not seem to operate with this same sort of approach. They not only in terms of the incredible velocities that those objects are able to achieve, but also in terms of their sort of relationship with inertial frames. It does not seem that they deal with with the necessity for the process of acceleration. It almost seems as if they choose their final velocity. They choose the final the final position where they want to go, choose their final velocity, and then just go there. So
Well,
it indicates to me that there's a fundamentally different approach to propulsion. And so your thoughts on that, please, and what that indicates to us regarding potential gaps between our understanding of physics and a fuller, more comprehensive understanding of physics that might exist out there.
okay, what I maybe you see other data than I see, but all the data that the government released, and by the way, I'm speaking directly to the head of the government organization that collects all the data within government. So all the data that was released publicly, all the images, all the videos, do not say anything along the lines that you just described. Nothing. There is no object that was measured to move faster than we can imagine. Nothing like that. All you see are fuzzy images. You don't know what they mean because the images are fuzzy. Those are the publicly released data that I'm aware of. If you have access to classified data that nobody else saw, that's a different matter. Then you have the report from the Nimitz, which was eyewitness testimonies, saying we saw TikTok, some objects moving from one location to another extremely fast. Once again, these are eyewitness testimonies, just like asking players in a soccer match, was there a penalty or was there not? And they would say, oh, yeah, the other side did this and that. How can you trust that? This is not data. Now, the other point about TikToks, just imagine driving on the highway. You see a black car in front of you. Then you look again at the rear view mirror, and suddenly you see the black car behind you. And you say, wow, that's amazing. It violates the laws of physics. It means that this black car had propulsion that goes well beyond the rockets that we developed. That's amazing. There is a black car doing crazy stuff in the highway. You just didn't figure out that it's not the same car. The car, you didn't take the license plate. You looked at the black car in front of you, and then you looked at the black car behind you. That's all. Nothing to do with propulsion. So when the people reporting about TikToks see an object in front of them and see an object behind them, it doesn't mean that it's the same object. You can have a swarm of objects that move around, coming in and out of view, and you are saying, oh, look at that. The object is there, and then immediately it's there. That's not evidence for anything. Just like on a highway, if you see two black cars, it's not the same car. It's not moving. So I say all of these statements are not supported, are not backed by videos that we can analyze, are not backed by any data that is publicly released. Now, of course, believers could say, I believe that the black car from the front is the black car from the back. And therefore, I believe that there is some technology that goes well beyond what our black cars can do. And therefore, this black car came from outside the earth. You can say that. You can say whatever you want. You can also say that the black car doesn't exist. You can say everything you want. But the point is that there is no scientific until you see the license plate and you tell me it's the same license plate of the black car in front of me as it is of the one in the back. And indeed, you confirm that it's the same one by very good data. Until then, you can't make a statement that is reliable. So my point is, all of these believing statements, like I think this and that, and so forth, they are not evidence. And of course, there is a possibility, and I wrote papers about it, of developing propulsion systems. And I'm actually the head of a project to accelerate spacecraft close to the speed of light. That's something I'm doing. I'm the head of the advisory board for developing that. I'm writing a scientific paper about developing propulsion close to the speed of light. Right now, I'm talking about it, but all I'm saying is this is not something that we have evidence to that is beyond any doubt. In the sky, we don't know that something like that exists out there. And in order to find out, we need to look out. So on the one hand, you have the scientific community ridiculing and saying there is nothing in the sky. Everything we see are just rocks, meteors or asteroids or comets. So they don't want to look. On the other hand, you have believers that say, yeah, for sure, I think I see this fuzzy thing and doing this and that. And the point is, both sides do not make sense. What you want is to develop instruments, just like FIFA used cameras during the soccer World Cup, to develop those instruments that will record what is really going on, will have license plates, will have the identity of objects clearly recorded. So you can tell if there is something in the sky. But as of now, maybe the government has that data. I don't know. I haven't seen it. If it exists, it's classified. I didn't see it. If you saw it, please share it with me. But I didn't see it, and I'm speaking directly to government. So it's not only I didn't see it, they didn't deliver anything that convinces me otherwise. And I'm saying I will collect my own data. That's what the Galileo project is doing.
And that's a wonderful um, objective to have. If we need more, we absolutely need more rigor in the field. There's no point in relying on anecdata and fantasies. But there's um, one last question that I had for you before. I'm sorry. Actually, Augustus, do you wanna take it away and ask your main sequence questions?
Hey, Dr. Loeb. I wanted to ask you, so in 2012, a Mars rover found Xenon 129 um, on Mars. And Xenon 129 is the process of creating that is through a nuclear weapon being deployed, or that's the process that that it's created, and it suggests that 350 million years ago there was some sort of an advanced technology that had a nuclear bomb potentially the size of the Empire State Building, creating a nuclear holocaust on that planet. The the comments that you've made about your theory with Oumuamua entering our solar system, and upon approaching its target, a dormant artificial intelligence is activated and then becomes the piloting operating system for it. I was wondering if you had any thoughts on those two technologies originating in a similar window of time for their creation, and do you think that this space object has been here before and just revisiting our solar system?
Well, Mars is interesting. I actually wrote a few essays in Medium about it in December because Mars probably developed life before Earth. It cooled earlier, and it lost its atmosphere about 2.5 billion years ago, roughly in the middle of its lifespan. So we exist now on Earth, and if Mars developed intelligent beings like us, twice as fast as Earth, just a factor of two, not a big factor, then it could have had a technological civilization on it before it lost its atmosphere. It's just a factor of two. So if at half of its lifespan it had the technological life, then we were uh, predated by a neighbor. And the question is, can we find any evidence for that? You mentioned xenon, but suppose there were high rises, cities on Mars, wouldn't we see them now? Even though it lost its atmosphere, everyone died. There was no breathable oxygen left, and all the water dried up. We know that there was liquid water on the surface of Mars. We see the evidence for that. But the question is, if you had cities, wouldn't we see them? And it turns out that if you calculate the impacts of asteroids over a few billion years since that happened, let's say there was a city 3 billion years ago, during a period of 3 billion years, you basically get 20 atomic explosions of Hiroshima energy output per square kilometer. So this is just from asteroid impact. So just imagine a city in every square kilometer or square mile, there are tens of atomic explosions over a few billion years. That will demolish all infrastructure. You wouldn't have anything left after having 20 atomic explosions per square mile. So if there were any buildings, they would be demolished to dust by now because of asteroid impacts. These are just rocks colliding with a planet over time. On Earth, we see such a collision every year. A collision of an atomic explosion equivalent occurs every year. It's a rock of the size of a person, roughly 2 meters in size, colliding with Earth every year. Every year we have a Hiroshima atomic explosion in our atmosphere from a rock. And it happens at an elevation of about 30 kilometers, so not much damage happens. But if there is no atmosphere, the explosion will not take place so high because there is no atmosphere. Usually it's the friction with the atmosphere that causes the rock to explode. So it will hit the ground. And in that case, Mars without the atmosphere will basically lose all the structures on its surface because it has no atmosphere to moderate the impact. So the impact will be on the ground. So that's an interesting point, that anything on the surface of Mars would have been demolished by now. We wouldn't see any evidence, any trace for that. And it's possible. In principle, it's possible that there was a technological civilization on Mars. You don't need visitors from far away to come back to your point. You asked whether it could have been a visit from another extraterrestrial civilization. You don't need that. In principle, there could have been a technological civilization just like us that happened when Mars was half the age of the Earth right now, and because then it had conditions quite similar to Earth. It had oceans, liquid water on the surface. It had an atmosphere. It was pretty much similar to Earth. So we don't know that. We don't know whether there was life or even intelligent life on Mars. And of course, one way to find out is to search the surface and do archaeology. For example, there are caves on Mars, caves that are called lava tubes. Basically, there was volcanic activity early on, and it created these channels where lava from volcanic activity flowed, and it cooled on the surface, and underneath the flow continued. So you end up with a cave. We see that in Hawaii, we see that in various places on Earth. These are called lava tubes, basically caves created by lava flows. And one way to find out if there was any uh, creatures that were sentient on Mars is to go into these lava tubes and look for any markings on the walls, just like we find some markings of ancient humans on the walls of our or caves here on Earth. And we haven't done that. We haven't explored the surface of Mars, so it would be nice to check. You mentioned xenon. That's a very interesting signature of potential technological activity, but it's not clear evidence. If we find any trace of past life, intelligent life on Mars, of course that will change everything, but we haven't really explored the surface there.
The I wanted to I understand that you're about to set out to find an object at the bottom of the ocean. We just all wanted to congratulate you on getting the needed permissions to do that. Can you tell us more about that project?
Right. So this is the first object that was detected from outside the solar system. It was found by the US government that is monitoring the atmosphere for any ballistic missiles, as a matter of national security. So they are monitoring the Earth, and every now and then they see a rock colliding with Earth. So just like I mentioned before, there is a meteor. A meteor is basically a rock that enters the atmosphere from outside, and then because of the friction with the air, it releases a lot of heat and it explodes. And so you see the fireball from that, which is very similar to an atomic explosion, basically. Depending on the size, of course, of the meteor, and we know that there used to be 66 million years ago, there was a rock the size of Manhattan Island that collided with Earth and killed the dinosaurs. That's why the dinosaurs went extinct. That's why we exist, to replace them. So, as a matter of survival, the US Congress tasked NASA to search for 90% of all the rocks bigger than the size of a football field that come close to Earth, just to protect us. Because if we see any of them that is about to collide with Earth, we are smarter than the dinosaurs. They did not develop telescopes. The human brain is much better than the body size of a dinosaur. We can develop telescopes, we can see them before they come and deflect them. That was the task that the US Congress gave to NASA in 2005. And that's why NASA developed Pan-STARRS, the telescope in Hawaii that discovered the first interstellar object. But also the US government is monitoring the atmosphere, and it saw this meteor in 2014 that I'm talking about. And it just cataloged it in a catalog of meteors. There are 273 objects in this catalog, and almost all of them are just rocks from the solar system left over from the construction project of the planet. So they're all bound to the sun. But here came this meteor at a very high speed. And together with my student, Amir Siraj, we were able to make the point that the speed is so high that it must have been unbound to the sun when it came into the solar system. In fact, it came into the solar system with a speed higher than 95% of all the stars in the vicinity of the sun. It was really moving fast at 60 kilometers per second. Of course, it could have had some extra propulsion, but it was moving really fast outside. So we concluded that this is the first interstellar meteor, because all other meteors that were identified in the past came from the solar system. Now, the US government confirmed our discovery, because at first my colleagues didn't allow our paper to get published. They argued that they don't believe the US government. They think maybe the US government is not reliable and so forth. And within a few years, I managed to get the US Space Command under the Department of Defense to send a letter to NASA confirming at the 99.999% confidence that this is indeed an object that came from outside the solar system. So the case was closed and our paper got accepted for publication. But at the same time, the US government also released data about the fireball. And that allowed us to conclude that the object was made of a material far stronger or tougher than all other space rocks ever detected in that catalog, 272 of them, because it only disintegrated in the lower atmosphere of the Earth, where the pressure on it was tremendous. So we could say that the material strength was at least 10 times more than iron meteorites. So it was really unusual. And the question is, was this object very different from solar system meteorites because it originated from a natural source that we are not familiar with, not a planetary system like the solar system, but something else? Or was it a spacecraft where the composition is some artificial alloy like stainless steel? And we can find out, because we can go to the meteor impact site and search for any relics, any fragments left over from the meteor explosion in 2014. And we are planning to do that. I got $1.5 million to support that expedition, and we are planning to go this summer and basically scoop the ocean floor and search for the fragments. And then once we find them, we will analyze their composition and try to infer whether it's a natural object or maybe artificial.
That's amazing. I just want to quote what you had said. We have a boat We have a dream team, including some of the most experienced and qualified professionals in ocean expeditions. We have complete design and manufacturing plans for the required sled, magnets, collection nets, and mass spectrometer. I'm just so grateful for that dream. I think a lot of people feel the same way, and just want to congratulate you again on all of the hard work that you've been doing and taking the time today out
Thank
of
you.
the busy schedule that you have to meet with this core community here at Clubhouse that has got your back 150,000%. I want to just pass the mic off to Josh. Hey, Josh.
Hi, Augustus. Thanks for the introduction, Prashant and Avi. Avi, thanks for coming on here. And I have two questions. The first one is, what is about the role of gravito-electromagnetism in the near light speed achieving propulsion tech that you're working on? And the second question is the biological effects that the phenomena or UAPs have on the human brain.
Right. So with respect to propulsion, let me say a few words about what we are starting to imagine now that goes beyond what was used in the past. So in the past, as was mentioned before by Prashant, we always used rockets, which can achieve up to a fraction of one part in 10,000 of the speed of light, really a small speed, roughly the speed that the Earth moves around the sun at. That's really a coincidence that the chemical propulsion, chemical fuel, chemical propellant allows us to reach this speed because it's just above the escape speed from the Earth. And it's a pure coincidence that chemical material can give us enough energy to escape from our planet. It didn't need to be that way. If chemical fuel was less efficient, we wouldn't be able to escape from Earth, and not to speak from the solar system. So we are able to escape from Earth and the solar system just barely. The speed is only a few times bigger than the escape speed from the Earth, and just a little bit bigger than the escape speed from the sun, if you move in the right direction, if you are taking advantage of the motion of the Earth as well. So we are lucky. This is not necessarily shared by all other civilizations, because if we happen to be near a dwarf star, the habitable zone is much closer in, and it's more difficult to escape from there. And anyway, that's what we used so far. We have launched 5 spacecraft out of the solar system. These are Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, and New Horizons. 5 in about 50 years. Now, what can we dream about for the future? So this project I mentioned before aims to get to the nearest star within a human lifetime. So the nearest star is about 4 light years away. And if you want to get there, let's say in 20 years, the spacecraft needs to move at a fifth of the speed of light. That's a very tall order, because it's 100 times, it's 1,000 times faster than chemical rockets, 1,000 times more. And chemical rockets are 1,000 times faster than Henry Ford's T-car, the first car, automobile that was produced. So if you think about it, the leap that we need to get to a fifth of the speed of light is the same as the leap from the first car to the first spacecraft, a factor of 1,000. And the question is, what technology can give us that factor of 1,000, moving close to the speed of light? And I looked into that about 7 years ago, because I was asked, and then found out that the only technology that we possess that can actually accomplish that is what is called light sails. It's just like the sail on a sailboat, which is pushed by wind. You can imagine a spacecraft that has a sail, but it's being pushed by reflecting light. And if the light source is sufficiently powerful, that push can be significant. So the concept is to have a sail roughly the size of a person, and the payload would be just a few grams, very lightweight, and then shine a very powerful laser on it and push it to a fifth of the speed of light. And it takes a distance of the order of 5 times the distance to the moon to do that. So that's the concept, and this project called Starshot is working on the necessary technologies for that. And by the way, if we had such probes passing through the solar system right now at a fraction of the speed of light, astronomers would not notice them. Because first of all, if they're small, the size of a person, they don't reflect much sunlight. But even more importantly, they move too fast for astronomers to pick them up. At best, they would show up in one of the images of a telescope, but then the astronomers would not know what to make of it, because you would see an object and then you would not see it anymore. So they wouldn't see it moving across the sky. So as of now, we don't know if there are objects moving extremely fast, especially if they're small, because we don't have the telescopes that can record them. So that's a technology that I'm involved in. I just wanted to mention another idea that I'm working on right now, which is a scientific paper in preparation, which is sort of, I mean, I don't know if it will ever be realized, but just interesting to keep that in mind. We are all familiar with positive masses, like the Earth has a gravitational pull that keeps us on the ground. That's the force of gravity. But if you imagine a negative mass, so imagine next to the Earth, there is a mass of the same magnitude, but it's negative instead of positive. So what it does is push everything away from it instead of attract everything towards it. So if Newton were to be next to that mass, Newton, the story goes that he saw an apple in the orchard falling down and realized, oh, gravity is an attractive force. That gave him the insight. But if he was next to this negative mass, he would see the apple running away from him. So imagine that we can engineer a negative mass and put it next to Earth. Now, the negative mass will push Earth away from it because it has negative gravity. The positive mass of the Earth will pull this negative mass along with it. So what you will end up with is this pair of masses, the positive and the negative, accelerating away, because the negative mass will keep pushing it and the positive mass will keep keeping the negative mass with it. And if you arrange those two to go together for the trip, if they have exactly the same magnitude of mass, so they will continue to move together, they can reach the speed of light. And you don't need any fuel. It's just gravity. And if you ask, is there a conservation of energy? After all, energy conservation is a sacred principle of physics. The answer is yes, because the kinetic energy of a negative mass is negative, and the kinetic energy of a positive mass is positive. And if the two masses are the same, the total energy is zero. So you start with zero energy and you end up with zero energy, even if this pair is reaching the speed of light.
Avi, one more. We have a few more minutes, but can I ask the second question about the biological effects that the phenomena or UAPs have on the human brain or humans in general? And thanks for your first answer.
Right. So I was about to get to that. Well, I mean, there is a professor at Stanford University, Gary Nolan, who looked into some of that, and there used to be a psychologist at Harvard, the Mac, that looked into the psychology of people that reported abductions, and so there are other people who are more experts on the impact on humans. Once again, from my perspective, I don't want to use humans as scientific detectors because, there is the Havana syndrome that diplomats experienced in Havana, in Cuba, and we don't fully understand where it came from and has nothing to do with extraterrestrials. Okay, so there are all kinds of impacts that you can have on the human body which are not fully understood. And just imagine humans being affected by some military equipment that the US government is using, and we are just not aware of it because we don't know what the US government is exactly doing at the time where these people report something. So we don't. There may be impacts on humans that were triggered by human technology that we don't fully understand, just like the Havana syndrome. But I don't have access to the evidence, and I don't want to use humans as detectors. I want to use instruments.
Thanks for your answers. And Augustus,
I think
would you like?
Prashant's up next.
Yeah, that would be me. And Dr. Loeb, thank you so much for this wealth of information and insights that you've shared with us. But I wanted to shift gears a little bit because I read through your post from this morning, and I would just like to point out, first of all, you certainly seem to have a very eloquent way with words. But I think you also talked about a very important topic whose ramifications go beyond just ufology or just the scientific community, academia, whatever the case might be, which is the truth. And you referenced towards the end of that article George Orwell's book 1984. Now, personally speaking, it always amazes me how it took me years to understand the profundity of the statement in 1984, where Wilson, the protagonist, states that freedom is the freedom to say that 2 plus 2 equals 4. On that note, I was wondering if you could please comment in terms of your own inner thought processes, the way in which you interface with life, with your professional career, especially in light of all of these various developments. And what do you think is the relationship between the speaking of the truth and the the enablement and assurance of our own freedom in the
Yeah,
most fundamental sense? Thank you.
yeah, I think that's an extremely important topic because academia, was originally conceived as a place where you can uh, research blue sky ideas, innovative ideas, that because you can acquire tenure, and that's job security that should guarantee that you can speak your mind. Unfortunately, when people get tenure, almost all of them are even more obsessed with getting honors and awards and recognition by their peers, and they basically create echo chambers where they not only say the same thing that we already know, just to uh, for other people to appreciate how smart they are, but also they educate the innovators, the young people who would later become scholars. They basically train them to repeat their mantras, so they create these echo chambers where their voice is heard louder, and they punish whoever deviates from what's already known. And that is really bad because it suppresses innovation, even when the truth is outside the box. And I can give you an example. There was this object, the interstellar object called Oumuamua, that I talk about in my book, Extraterrestrial, and it clearly did not have a cometary tail. There was no coma, no gas or dust seen around it. We can easily tell when a comet is a comet. If you look at the Britannica, Encyclopedia Britannica, there is a definition. It must have a coma in order to be a comet. If it doesn't, then it's an asteroid, just an object without ice on its surface, so it doesn't evaporate when it comes close to the sun. It doesn't release any dust or gas. Nevertheless, Oumuamua appeared, this object from interstellar space, and it didn't show any cometary tail, nothing. Yet it exhibited a rocket effect. There was a push away from the sun that you associate with comets usually. So at first people called it a comet, then they realized, no, it's not a comet because we don't see the signature of a comet. So they called it an asteroid. Then they saw that it's pushed away from the sun, so they didn't know what to make of it. So I said, maybe it's artificial in origin. And once I said that, maybe it's technological from another civilization, immediately all the experts lined up and said, no, it's natural, period. We are 100% sure that it's a rock that is natural, of a type that we've never seen before. And then, of course, they went through a process of trying to account for it. And all the objects that they came up with were never seen before. One was a dust bunny, a collection of dust particles 100 times less bound than less dense than air, and that would not survive coming close to the sun and being heated by hundreds of degrees. Then they suggested a hydrogen iceberg, a chunk of frozen hydrogen. We've never seen anything like it. And I showed that such an object would not survive the journey in interstellar space. It will be heated by starlight and will just evaporate. So then they said, oh no, it's a nitrogen iceberg chipped off the surface of a planet like Pluto. And then I showed, no, the mass budget does not make it viable because you just don't have enough solid nitrogen to account for a large enough population of chips, so that one of them would be Oumuamua. So now, on Thursday, there was this Nature paper with the latest idea that was proposed. They said, oh no, it's actually a mix of hydrogen with water. And all the journalists jumped up and down and celebrated and said, yeah, that's a simple explanation, and why did we not think about it before? And they celebrated and laughed at the idea that it might be extraterrestrial technology that produced it. And then I figured out within a day that they made a mistake in their energy equation. They didn't conserve energy. They didn't account for the loss of energy by the need to evaporate the hydrogen from the water. And when you account for that, the model doesn't work. So we wrote a paper about it yesterday, and the reporters did not come back and revise their stories, except for two. One of them is uh, Earth and Sky, that basically published something that I wrote about it. And the other one is The Times in London, which is a very prestigious newspaper, and they told me that they would write another report on Monday. So aside from these two, all the major journals just published the original story, and some of them told me, we don't want to confuse our readers. And I say, you are misinforming your readers. You have to report about the fact that this paper did not conserve energy. That's a trivial point. And in Scientific American, even, they didn't come back to me. And you ask yourself, how can a scientific journal like Scientific American not even respond to me on this issue and basically just ignore it? They will give the narrative they want to their audience, to their readership, without being honest about it. They know about my paper. They know that energy conservation is claimed not to be satisfied. So they can just mention that, but they will not, because they already delivered the original. And I say, what advance did we make over the past 4 centuries? Because if you go back 4 centuries, there was this trial of Galileo. At the time, there were people convinced 100% that the sun moves around the earth. And Galileo said, no, I see evidence that it may be the other way around, that the earth moves around the sun. So then he was put in house arrest, and the Inquisition trialed him. And I just got all the documents from this trial by the Catholic Inquisition. I got it in the mail actually 2 days ago. Someone from Rome in Italy sent it to me because they like my debate with the mainstream. And I asked, why are the prosecutors back then, why do they resemble so much what we see nowadays? these journalists not reporting the full truth, the mainstream of scientific community jumping up and down about a model that doesn't satisfy energy conservation. If I weren't alerting people to this fact, they would just celebrate the model and case closed and forget about it and move on. How can we trust science this way? So I'm really worried about the status of science. And um, I'm also worried that at the same time you have the mainstream of theoretical physics, involved in all kinds of imaginary speculative ideas, like, for example, extra dimension string theory. So it's not as if there are no speculations out there. They're even worse because, yeah.
So really quickly,
Do
Dr. Loeb, thank you so much for that. Was absolutely brilliant, a brilliant sort of insight regarding the state of academia. And yes, it is sweet to know of what the Gospel of John says in chapter 8, verse 32, that the truth will set you free. But for all of you who hear my voice right now, let us also not forget that the lies will set you up. And on that note, I'll hand that over to Augustus.
do you believe that you are being censored or throttled by the academic, governmental, military establishment?
No, because I'm completely free in the sense that I don't care how many likes I have. I didn't do any criminal act that I didn't sign any NDA with the government so that the government can tell me that I released the information that was classified. So I have no such information. Therefore, they cannot prosecute me on that. I have tenure at Harvard University. I was chair of the astronomy department at Harvard for 9 years. So I'm part of the establishment in a way. I'm just loyal to my childhood curiosity. I will not surrender to social pressure. I will say what I think is right. And I don't have any account on social media, so I don't even check what Twitter says about me. What are the tweets that some of my colleagues, the negative tweets, the attacks, the personal attacks? I don't. I'm completely protected from that because I don't pay attention to that. I'm just trying to follow my common sense, and what I find is that common sense is not common.
Thank you. Hey, Josh, you want to try to round everything off here?
Sure. Well, thanks, Avi, for your time here. And if you have any um, thing you would like to finish with, that would be fine.
Yeah, I think by taking the road that was not taken with the Galileo project, with everything else I'm doing, there is a chance that we will find some low-hanging fruit, simply because nobody took that road. There is this poem by Robert Frost that it made all the difference for him, for the poet Robert Frost, to take the road not taken. And as far as for me as a scientist, taking the road not taken is the opportunity to find some low-hanging fruit, and because nobody walked there, nobody picked it up, and obviously you will hear about that. So just stay tuned. There is a potential that within a year or a few years, we'll really discover clear evidence for something that was not recognized, which I think some of you believe exists, but I'm just trying to find the evidence that will substantiate it. And of course, once we find it, it will become mainstream because nobody would be able to deny it. And then everyone would say, oh, of course, there were people discussing it a long time ago. But the point is to find that evidence that nobody can dispute.
Last question for you because I know you have to go.
Go ahead.
What is your vision for the role that Project Galileo will play in the preservation of the human race?
Oh, I think it's extremely important. That's the topic of my book, Interstellar, that is supposed to come out in August 2023. Thank you for asking this, because that's exactly the question that I'm trying to answer in the book. I think it's extremely important for our survival to figure out who else is in our cosmic neighborhood and to learn from them. If there is a more intelligent technological civilization, we should learn from it. It's to our benefit. And I talk a lot about that in my book. So I encourage you to stay tuned and get it when it comes out in August.
Brilliant. Thank you, Dr. Loeb. Yes, folks, not all those who wander are lost. Let us never forget that.
Thank you again for your time today, Avi. I really know you got a super busy schedule, and you taking the time out to come and speak with us really means the world to a lot of people here on Clubhouse and to us, Prashant, Josh, and myself. Thank you.
Thank you for hosting me. And if anyone wants to follow on updates regarding my work, I usually post them every couple of days on Medium. You can see the link. And you will find all the updates there. You can subscribe for free. I don't charge anything. You will get regular updates by email for free if you sign up.